Yes, good morning, friends. Yes, we are still on our series of derivatives, and today we are looking at the chain rule, after which I will introduce us to integration. Yeah, we looked at the earlier rules: the constant rule, the power rule, the product rule, and the quotient rule. Yeah, but then there are cases whereby we are differentiating composition of two or more functions. Yeah, you're differentiating a function which is a function of another function. So in this case, I'll refer to them as chains, and so we use chain rule to handle them. Yeah, so we are seeing if f and g are both differentiable, and fx is the composite function defined by fx is a function of g, yeah, or for which g is also a function of x, yeah. X is a function of g, but for which g is also a function of x, yeah. Then f is differentiable, and f, or the derivative of f, is given by the product. Yeah, we are getting the derivative of the outer functions times the derivative of the inner function. That's how we do with the chain rule: the derivative of the outer function and then the derivative of the inner function. But now you may be disturbed by what is inner, what's outer. Yeah, we are going to get a clear understanding of that. Recall we've said here we are differentiating compositions of two or more functions. A function which is a function of another function. Alright, so that's a simple formula. You get the derivative of the outer function and the derivative of the inner function. Yeah, but that's after knowing which one is inner and then which one is outer. Okay, so you have this example: if y is a function of u and u is a function of g. Hope you're seeing that chain. Y is a function of u, but u is a function of x. Altogether, yeah. But we are interested in getting the derivative, or we are trying to differentiate y in respect to x. All right, yeah. And then we are saying you're going to have dy du, or the derivative of the outer times the derivative of the inner function. I repeat, y is a function of u, but u is a function of x. Yeah, and let me say education is a function, or education is influenced, or education is determined by attendance. Okay, but attendance is also determined by something. Let's say how you eat at your hostel, whether you're eating or not. Yeah, together. So if you want to see to get the derivative of your performance in respect to how you eat, then we use the chain rule. Okay, yeah. Note, in the chain rule we work from the outside to the inside. We differentiate the outer function and then multiply with the derivative of the inner function. Alright, we're having an example here. We're having several examples. You're told fx, we are trying to get the derivative of f in respect to x. Okay, or the derivative, yeah, of this function in respect to x. This is a chain rule. Here we use a chain rule. We are having compositions of two functions. There is an inner function known of 2x cubed together plus z, and then there is an outer function, the one you're seeing, which is 2 the power 6. It has this inside one, but it's the power 6. Okay, let's go to the solutions. Yeah, so if we are presented with such functions, yeah, we are presented with such functions. Okay, we are going to create two functions, y and u. Let me start with let me first say, okay, we are having u the inner function and then y the outer function. Yeah, let me start with let me first have my y outside here. Yeah, since we said we start from, okay, Okay, we start from the outside, the inside. Let me first have my y here. Okay, y equals to this. Y is equivalent to that. Okay, so we are letting the inner to be u. Yeah, so we are letting the inner function to be u. Yeah, so this inner function is u. Okay, the inner function is u altogether, and then the outer function, which is equivalent to this inner function, yeah, bracket to the power 6, is our y. Okay, so now this entire thing is the outer function. This is the outer function, but recall the outer function has a u inside, so keep the u inside. So we are letting this to be our outer function. Yeah, y equals to u bracket to the power 6. Alright, so we're having two functions. We have the inner one, this, which you're seeing, and then the outer one, this. As you can see, the brackets. Yeah, the bracket shows the outer one. Yeah, and it's to the power 6. But recall the outer one has a u inside, so don't ignore the u and you just have brackets to the power 6. Alright, so the outer one has something inside. But when we'll be dealing with the outer function, we'll just leave the inner function unattended to. We'll just keep it there, we just know it's there, but won't disturb it in any more when we are dealing with the y. When we are dealing with our y. Recall we said if we are to deal with this, we are going to get the derivative of the outer function, which is y, times the derivative of the inner function, which is u. Yeah, if I'm to take you back to our formula here, yeah, the y dx will be the derivative of the outer function y times the derivative of the inner function x, right together. Alright, so that's the first step. The first step is knowing or is identifying the inner function and then the outer function, which we've done. Yeah, we've let u to be our inner function, and then we've let y to be our outer function, to be our outer function. Alright, so let's move on. And we say the formula is you get the derivative of the outer function and the derivative of the inner function. Yeah. So, okay, this may still someone will ask me, why are you now starting with the inner function when you should have started with the derivative of the outer function when you're calculating? Yeah. Alright, so here, okay, let me start with the outer function to avoid people wondering why I'm starting with the outer function. So, alright, alright, so we get the derivative of the outer function. The outer function is y, and we're differentiating it in respect to u. So it will be dy du. The outer function is this. This is the outer function. Yeah, that's our outer function. We are differentiating it in respect to u. Okay, so we use our power rule. In this case, we assume it's the power 6. So we get 6 minus 1. Okay, we multiply by the power, which is the 6 you're seeing here, and then we subtract 1 from the power. That's why you're seeing we are having 6 into u to the power 5. All together, 6 into u to the power 5. Yeah, just simple. We multiplied by the power, which is 6, and we subtracted 1 from the power. That's how we came to that. 6 into u all to the power 5. Alright, and then we need to get our du dx, the inner one, the derivative of the inner one. Du dx, it's u in respect to x, and it's very simple. We made a power rule here, so we are multiplying by the 3. Okay, so let me just put this aside. Let me work it out from somewhere here before we get to that answer. Yeah, let me work it out from here. Okay, let me work it out from here. Let me work it out from here. Okay, let me work it out from. Let me put it here. Okay, we are looking out for du dx. Yeah, du dx. Du dx. Yeah, if you recall, we said we multiply by the power and then we subtract 1 from the power. So our power is 3, so we multiply by the 3. Alright, so it will be 3 times, okay, 3 times, let me put this to avoid, 3 times 2x to the power 3, and then this is minus 1. We subtract 1 from the power, plus, everything is plus, it's plus 0. Plus 0. Why plus 0? Because this 7 is a constant. Yeah, by being a constant, it means its derivative is 0. So you multiply by 3 and then subtract 1 from the 3 and then plus 0. So this gives us 6x squared. Yeah, and then this gives us the 6x squared. It gives us the 6x squared. Yeah, it gives us the 6x squared. That's how we manage to get the derivative of u in respect to x. Okay. Yeah. So now we've gotten our dy du, which is this 6 into u to the power 5, and then we've got our du dx, which is 6x squared. And then we said to get a derivative, we just multiply these two. That's why I think we are now having 6 into u to the power 5. This is the dy du times the du dx, which is 6x squared. Right together. But to recall, our u, we know this u, the inner one, we know it. Yeah, that's why you're saying recall u is 2x cubed plus 7. So at this point, we can replace our u with the u we stated earlier. Alright, so it will be 6 in 2. We'll replace the u with this, with our u, and then times 6x squared. If you want, you can break it further, but if you leave it at that, it will be fine. So that's how we deal with the chain rule. And I said it's very simple. You identify the outer function and then the inner function, and then you get the derivative of the outer function times the derivative of the inner function. Yeah, when you're getting the derivative of the outer function, you let the inner function to be u, and then you won't disturb it while calculating. You'll just use the outer power, you multiply it into the function, and then you subtract 1 from that power. And then after, in the later stages, you can replace our u with what it stands for. Yeah, that's how we got, well, that's how we use the chain rule. Alright, thank you. Let's move on. We had 2 examples. There's another example, this one. 3 divided by x squared minus 3 squared. Okay, that was our example 2. 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 Alright, so if you're having that example, yeah, if you're having such a case, you can simplify it. If I'm having a 3 dividing 2 such a function, it should be, in simple terms, it's like having this 3 multiplying into the denominator. But to deal with this division and so on, I make the power of the denominator will become negative. Yeah, so it becomes 3 times the denominator, and then the power of the denominator will become negative. So meaning this function is the same as that function. Yeah, this function is the same as that function. You just multiply by the numerator, and then you change the sign of you change the sign of the power of the denominator. All right. Yeah, so that's how we deal. That's the first step. After knowing that, then it becomes easier. These other things become too easy for you. They become too easy for you. Yeah, this is a simplified form of that. I just get the 3, I multiply into the numerator, and then the sign of the numerator, the sign of the denominator, of the power of the denominator changes. If it's a positive, it becomes a negative, and if it's a negative, it becomes a positive. Yeah, it changes. So that's the first step. That's the first step. Yeah, so from that, now we can use our chain rule. Yeah, from that point, we can use our chain rule. We can use our chain rule. Okay. So like we said, for the chain rule, you identify the outer and then the inner. So in this case, let u be this inner function, or let the inner function be u. That's why you're saying let u be equivalent to x squared minus 3. Yeah, we are letting the inner function to be u. This one now. So we just let u, or let the equivalent, the inner function be u. Okay, that's it. We like that, and then the outer function will be now. The outer function will be 3. The 3 into u to the power negative 2. This is the outer function, but recall the outer function has a u inside. Yeah, so just put that u inside. You don't deal with it while you are differentiating, but rather you recall it and you always refer to it. All right. So this is our u. Yeah. So u du dx is the same as 2x. This is the derivative of x squared minus 3. It's just the 2x, 2 minus 1, which is 2x. Negative 3 is a constant, so it's a 0. Okay, then the derivative of y, which gave us this, okay, if I may go through it, the entire bit of it, it will be this. Okay, so it's 3 into u to the power negative 3. We multiply by the power and subtract 1 from the power. The rule stands. Yeah, so it would be negative 2 times just a minute, negative 2 times